Video, I wanted to give a little more guidance on the homework 6 for operator overloading. So first, you're supposed to represent rational numbers. So these would be a number with a numerator and a denominator. So your class will basically have two uh, integer values, and it will be quite a bit like the pair class that we have from our class. The notes for the pair class are in week 9. So you see in the pair class that there's a double x and a y. For rational numbers, you only really need an integer for the x and the y, or the numerator and denominator. So that's the nature of the class. You're not going to have any memory leaks because you're not going to create any arrays or anything like that. So you don't have to worry about that. It's a pretty simple class as far as the data goes. Now the operations that you need to support are defined here. So if you need to add two rational numbers, the resulting rational number has this in the numerator and this in the denominator, and so on and so forth. For negation, you can just do the negation of the numerator. And then to check if something is less than something else, it really means that the numerator times the other's denominator is less than the denominator times the other's numerator. Or sorry, the numerator, the other's denominator, the other's numerator, and this one's denominator. Anyway, it's defined here. And for two things to be equal, fractions or rational numbers can be equal even if their exact numbers are not equal. So like 5 over 10 is the same as 1 over 2. So that's what we'll do with equality here. We're going to also support this kind of funky operation, star in front of a rational number, which will just flip it. So if you have a statement like this, it would be 2 comma 5 as a result, or 2 over 5, because it flips the 5 over 2 right here. And for using a rational number in a cout statement, you want it to appear as a slash, 5/3 in this case. This is all tested, almost all of it's tested in main CPP. You got the simpler operations like, is the numerator actually a 5 and denominator actually a 2? And then you've got these operators being used, minus and plus, negation, a more complex piece of math. The last thing that happens is it flips the whole result. I think, actually, I'm not sure if star A happens before plus or not. It doesn't matter. This is the result. And here's just an example of flipping the result. And then here's checks on equality and comparisons, less than, equal, and so forth. We'll talk about those in a second. You also want to support the two different kinds of increment and decrement. So post increment, as we discussed when we had class before, an operation like this will increase the value of A, but will give the old value to B. So B gets a copy of A's value before A increases. And for A to increase, you know how you work with fractions, 5 over 2, and that's supposed to go up by 1, that would be 7 over 2. So you just add the denominator to the numerator to get a larger numerator. So you see here that B retains the old value, but A has actually increased. And then if you do it the other way around, pre-increment, this is where it increases before B gets a copy of it. So they both have the same value. Decrement's just the other way around. Converting, we talked about this in class as well. If you have a line of code that forces your class object to turn into something else, you can just define an operator for what that means. And in this case, with fractions, it'll just actually do a division. So you'll get a float result. Here's the case of printing. This, as far as the test is concerned, is basically if it proceeds past this line of code, it must have worked. So it's just always success. And then there's the other way of using streams. If you want input, it's called cin, and you can feed in input into a rational number. So the way this assignment is set up, it's already got, it must already be a rational number. There's no constructor that has no arguments. So you have to already have a rational number, but then you can change its values by typing on the keyboard. And the way it would work is it's supposed to get 2 integers. So this thing should wait for you to type 2 different numbers with a space between them. And then it'll print out what you typed, and that's supposed to say success. Or it'll always succeed, but you'll print out whatever it is you typed. And here's the typical makefile. So what we need to talk about a little bit is how to define these operators. So we've talked some already about some of the basic ones. Here's the pair class again. Plus, minus, times, divide, and so forth, they're all going to work like this. We're not going to do any situations where your fraction is going to add with another number. It's always going to add with another rational number. So it's always going to be this kind of operation where it's rational and rational on both sides. And if we look at the code for that, that's just a case of you know that you're being executed on an existing rational number, so you already have a numerator, and then you can get the others numerator. And this is allowed even though the x or the numerator is going to be private, because this function is defined inside the class. So classes can access private data of other objects if it's the same class. So pair and pair is the same. And most of these operations will have const in their argument. There's no reason it should be changing this pair or this rational. And the result would be const because it gives back a new value. And this just calls the constructor and gives it back. So these operations will all work like that. So that's pretty straightforward. The negation is going to be like, we have an example here with this squiggle. The way that's defined is it just, it has no input because it's only operating on one object, and you just do whatever you got to do. This actually is going to be this, almost the same. It's just in the rational, only the numerator goes negative, and then you return it. So that's easy enough. Now these comparison operators, they're also pretty straightforward. It's just, you might not want to define every single variation. So if we talk about less than sign, well, that's just another operator less than pair versus pair. And if you look at the C++reference.com notes, it is one of those cases where it's operator op, a regular overloaded operator. It supports less than, greater than, and a whole bunch of different variations. And it's going to be a scenario where it's between two things. So it's going to be a rational number and then the less than sign in a rational number. When that's the case, you just define a typical function as if it were plus or minus or whatever. And of course, the return type should be a bool. So if we look at their fraction example, I think there's a case. They have equals and not equals, but they're bool return types. Now notice they've actually defined this outside of the class. If you define it outside of the class, you have to give 2 arguments because it won't be able to assume that one of them is a fraction or rational number. So it's the same thing, it's just you have to give 2 inputs. And then also, if it's defined outside the class, you can't access internal data, the private data, which would be the n and the d in this case. So you have to use a function that gives you access to the internal data, in this case num and din. So you can define these outside the class if you have functions that give you the private values. And notice this case just refers back to this case so that they can avoid writing all the silly variations. So this just flips the result of calling this function. And then they've also got examples up here of ignore the in line. That's just an optimization for the compiler. They got all these variations that just truly use only one version of the function, actually 2 different versions. So they, in this set of examples, only define what it means to be equal and what it means to be less. All these others just refer to the one that's been defined. So this one, greater, just refers to less than, and less than equal just refers to the opposite of greater, and greater equal is the opposite of less than. So they only really had to do the code once. You can likewise do this. Again, don't worry about inline. You can put it if you want. These can be all defined outside of the class because you're giving it the two inputs. And then for the equals and not equals, you can just define what it means to be equals, and then it'll do the not equals automatically. There's another way to do this, which is down here, but I wanted to bother with that case. I'd do these cases. So this is how you would do it if you don't want to do it inside the class. You want to make these functions outside the class. If you make the functions inside the class, it'd be just like this, except instead of plus, it'd be equals equals or not equals or whatever. And the difference is you only have to give one input. So that's these cases. And this case is where you have, it's another op situation. It's a star, and the situation looks like this. It's a star before the object. So you define a function that has no arguments, but it's still inside the class as usual. So that's just like the negation case. And now for this, cin and cout have to be handled differently. The difference here is you're overloading this operator, but you're technically overloading it for this object or this class. This is an OStream class, and cin is an iStream class. So if you're going to overload it for that, then you might have to make this function get access to private data. It depends how you define it, but suppose you want to define this operator so that it can read the private data of this rational class. But you have to define it in terms of cout as the first argument. So what that looks like is you define a function called operator less than, whose first argument is a OStream type of thing, and then your rational class. Again, you have to do it that way because it's not true this time that both sides of this are rational numbers. Every other situation, both sides were rational numbers, so you could define it inside the class. But in this case, you're actually getting a different kind of object in the first, the left side of the operator. So you have to define a function that takes the first argument as an OStream, which means it has to be defined outside the class, because anytime you define something inside the class, the first argument is always something of your class type. If you want the first argument of the operator, the left side of the operator, to be different than your class, you have to define it outside the class. Now, if you have methods that allow you to get the private data, the getters and the setters, then you don't need to do this thing called friend. But if you want to keep the data private and you don't have any way to get the numerator, denominator, or whatever, then you might have to use friend. What friend says is when you're defining your class, you can say this function, which will be defined probably elsewhere, should have access to all the private stuff inside this class. So that's all that means. If this word friend appears before the name of a function, then the definition of that function can access the private stuff of the class. So that can sometimes make it easier because down here, when we define this method, notice it's not pair colon, because it's defined outside the class. Then we get to access the private data of the class. So it's not a difficult function to define. It's just you have to know what the difference is. The difference is the left side is not a rational number, so you cannot define it inside the class. It's not a class method. It has to be defined outside the class like this is, and if you want it to access private stuff inside the class, it has to be a friend function. Lastly, you need to support cin, this scenario. So again, it's an operator, greater this time, whose left side is an iStream, instead of an O stream. And the right side is a rational number. So you're going to define a function just like this, except for O stream, it'll be I stream, and the arrows will be the other way around. And I think we sort of actually avoided this mostly in the class, but if you look at how, just the order I did things, if you look at how we do simple input and output, you can see how cin is used. So like this. If it cin arrow arrow to an integer variable, it'll treat what you type as an integer. If it does cin into a float variable, it'll treat what you type as a float. If you cin into a string, it'll treat what you type as a string, and so forth. So in your function, you're going to have an iStream object, which you might call stream, and your arrows would go the other way around, and they'd feed into px, and they'd feed into py, just like this feeds into I and x. So it'd just be like those two lines of code, and then you just return the stream. So try that out. Let me see if there's anything else that needs to be covered. I think that probably covers everything that's you're being asked to do. Oh yeah, this conversion to double. Do we have an example of that? Yeah, we have an example here in the pair. How do you convert a pair into a double? In this case, it's multiply, but in your case, it's going to divide. And make sure you convert to a double when you divide. You don't want to divide two integers. So what happens here is anytime your object is used in a situation where it has to turn into a double, that function will execute. And the rest should be, oh, and so plus plus minus minus, we have two versions in the pair example. The way these are defined, again, what we talked about in class, but they're kind of funky. If it's the left side, the pre-increment or pre-decrement, it's the simple case, no arguments. If it's on the right side, it's a post. You have to have an integer argument, which will always be 0, so you just ignore it, but it has to be there. That's why we have two versions of this. This one is post-increment. This one is pre-increment. And the difference will come out to be in post-increment, you actually change the values of this object of the pair, but you give back the old values. And in pre-increment, which is this version, you change the values and then give back a copy of yourself. The way you can give a copy of yourself is to dereference yourself. So hopefully that helps. Get on Discord and ask questions there, or catch me on Skype during the office hours, or send an email. And let me know if this strategy of like a video and some notes is working, or if you'd like a change. Thanks very much.